So some miscellaneous examples on Taylor's theorem and Maclaurin's theorem. So the example is expand tan x, and the another function is log root 1 plus x divided by 1 minus x. So first problem, expansion of tan x. That is about x is equal to 0, or about x point. Okay. So y or fx is tan x. Fx is tan x, the given function, and then find its derivative f dash x, f double dash x, f triple dash x, and find their values at 0. So either denote y or f, and so the value at 0 is tan 0 is 0. Then f dash x, that is y1, is sec square x, and is 1 plus tan square x. Sec square x is 1 plus tan square x, and tan x is y, so it is 1 plus y square. And then value at 0 is 1 plus tan 0. Tan 0 is 0, so 1. And then y2, so the second order derivative is derivative of 1 is 0, and the derivative of y square is 2y into y1. Okay, that is the derivative with respect to x. So the derivative of x square is just 2x, but it is y square, so 2y into derivative of y is y1. And then y2 0 is what? Is 2y0 y1 0. So y0 is 0, so we have this is equal to 0, y2 0 is 0, value at 0 is 0. Then y3 is what? The derivative of this 2 is constant, and then y1 y, that is the derivative of u v as it is, plus 2 y2, that is u into v root. There is 2 y1 square, 2 y2, and then substitute x at 0. So y1 square, y1 0 square, y1 0 is 1, 1 square is 1. So 1 into 2 into 1 is 2. And then 2 y0 is 0, y2 0 is y2 0 is also 0. So we have 0 at this place. So 2 plus 0, that is 2. Similarly, y4 is what? The derivative of this quantity is 4y1 2 into derivative of y1 is y2. So the derivative of x square is 2x, but it is y1 square, so its derivative is 2y1 into derivative of y1 is y2. Then u into v rule, 2 as it is, y3, u derivative of v plus v derivative of u, y1 y2, plus 6, this is 6y1 y2 plus 2y y3, and then value at 0, y4 0. Y4 0 is what? 6y1 0, 6y1 0, y2 0, y2 0 is 0, so we have this is equal to 0, 6 into 1 into 0. Then 2y0 is 0, y3 is 2, but it is equal to 0. So y1 y0 is 0, so this quantity is 0, and so we have answer 0. Then y5, the derivative of this quantity, 6 as it is, u into v rule, y1 y3 y2 that is y2 square, plus again u into v rule, 2y y4 2y y4 plus 2 y1 y3, right, that term 2 y1 y3, and that 2 y1 y3 and this 6 y1 y3 becomes 8 y1 y3. This is after simplification. So then value at 0, we know that y1 0 is 1, y3 0 is 2, so write 8 into 1 into 2 plus y2 0 is 0, so this term is 0, y0 is 0, this term is 0. So we have the answer 16. So tan x is equal to, the expansion is what? The Taylor's theorem is what? Fx is equal to f of 0. In the place of f, use y0 plus x f dash 0. That is x y1 0. So x square by 2 factorial f double dash 0 means y2 0. X cube by 3 factorial y triple f triple dash 0, that is y3 0. In this way, x4 divided by x raised to 4 by 4 factorial y4 0 plus x raised to 5 by 5 factorial y5 0, and so on. And then substitute the values. Y is, or yx is what? Fx is what? Tan x, and then y0 is 0. So this term, first term is 0. X into y1 0. y1 0 is 1 plus x cube divided by 3 factorial y3 0 is 2. Then next term is 0, y4 0 is 0, y5 the term y5 x raised to 5 y5 factorial into 60. So this is x plus x cubed by 3 plus 2 x raised to 5 y15. So this is the expansion of tan x. Okay. So this is some another notations. In the place of f, use y. Okay. So and the derivative are denoted by, in the place of f dash, f double dash, f triple dash, denote y1, y2, y3 as the derivative. Similarly, the next problem is log root 1 plus x divided by 1 minus x. So log 1 plus x expansion is this, x minus x squared by 2 plus x cubed by 3 and so on. Log 1 minus x is just replace x by minus x. We have this answer. And so log 1 plus x root 1 plus x 1 minus. So root means raised to half. And log a raised to m is m into log a. So we have 1 half log 1 plus x divided by 1 minus, and log a by b is log a minus log b. So we have this answer, 1 half log 1 plus x minus log 1 minus x. Then 1 half, substitute log 1 plus x as this value minus log 1 minus x as this value. And after an effect of negative sign, we have all these terms are positive. And then we have x plus x is 2x. Then minus x square by 2 plus x square by 2 get cancelled. Then x cube by 3 and x cube by 3 become 2 times x cube by 3. In this way, x raised to 5 and x raised to 5 by 5 becomes 2 times x raised to 4. And here is right plus side, it is not minus, plus x raised to 7 by 7 again is a 2 times. Okay, and so add all these terms. We have this answer and then take 2 as common. So we have x plus x cubed by 3 plus x raised to 5 by 5 plus, it is not minus, plus x raised to 7 by 7. This is the expansion of log root 1 plus x divided by 1 minus x. Then next is prove that tan inverse x is this, and hence find the value. So in the place of fx, we use the notation yx. Yx is tan inverse x, or we can use fx as tan inverse x. Then f of 0, tan inverse 0 is 0. Then find f dash x. F dash x is 1 by 1 plus x square. Okay, f dash x or y1. Then 1 by 1 plus x square. 1 plus x square raised to minus 1. And this expansion is what? 1 by 1 plus x. Expansion is 1 minus x plus x square plus x minus x cube, and in this way. So here is x square, 1 by 1 plus x square. So 1 minus x square, it's plus x square square is x raised to 4, minus x square cube is minus x raised to 6, and so on. And then value at 0 is what? This is f dash x, suppose. So f dash 0 is 1, y1 0. Okay. Similarly, y2, its derivative is minus 2x, 4x cube minus 6x raised to 5. And then value at 0 is 0. If you substitute x at 0, we have answer 0. Then y3 means next order derivative. If you use the notation fx, then write here f dash x, here f double dash x, f triple dash x, f raised to 4x, f raised to 5x, and so on. Okay, and then use the Taylor's theorem as fx is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 f triple dash 0, and so on. So in the place of y, use the notation f, use the notation y, and in order to denote the derivative, instead of f dash, f double dash, f triple dash, you use suffixes y1, y2, y3. Y2 means second order derivative, y3 means third order derivative. So its derivative is again this. So very simply we have this derivative, and then value at 0 is minus 2. Then when again the derivative of this quantity minus 2, derivative is 0. This is the 24x minus 120 x cube, and so on. The value at 0 is 0. Next order derivative 24 minus 360 x square plus so on, and the value at 0 is 24, and so on. Then you write the you write the Maclaurin's theorem, that fx is equal to f0 plus x f dash 0 plus x square by 2 factorial f double dash 0. So instead of f, use y notation, and in order to the derivative, use suffixes. Okay, that is f0 means y0, f dash 0 as y1 0, f double dash 0 as y2 0, f triple dash 0 as y3 0, and just substitute the values fx or yx is tan inverse x, y or yx is tan inverse x. Then y0 y0 is 0, then x y1 0 is 1. In this way, x square by 2 factorial y2 0 is 0, x cube by 3 factorial y3 0 is minus 2. So in this way, the next term is 0, and the next term is x raised to 5 by 5 factorial into 24. So we have, this is the expansion of tan inverse x as x minus 2 by 3 factorial. 3 factorial means 6, and 2 by 3 is 1 by 3. 5 factorial is 24 into 5, and that is 24 get cancelled, 1, so divided by 5. In this way, the next term is x minus x raised to 7 by 7. So if we substitute x is equal to 1, this is the expansion of tan inverse x. We substitute x is equal to 1. We have tan inverse 1 is 1 minus 1 by 3 plus 1 by 5 minus 1 by 7. And tan inverse 1 is 45, pi by 4. Because tan pi by 4 is 1. And therefore pi by 4 is this, and therefore pi, value of pi is substitute shift this 4 in bracket, we have this. So this is the value of pi. So hence find value of pi. So this is the value of pi. Obtain the expansion of e raised to sin x up to the first 4 terms. So denote fx or e raised to sin x as fx or yx. So fx as the notation. The f of 0 is e raised to 0 is 1. Then find first order derivative, find f dash x, f double dash x, f triple dash x, and their values at 0. Okay. So f dash x is e raised to sin x, derivative e raised to sin x into derivative of sin x is cos x. So that is e raised to sin x is just fx cos x. And therefore f dash 0, we have to find value at 0. F dash 0 is what? E raised to 0, sin 0 is 0, e raised to 0 is 1, and cos 0 is 1. So 1 into 1 is 1. Then second order derivative, f dash x, u into v rule, fx into cos x derivative, u into v rule, fx, f dash x cos x as it is, and fx as it is, the derivative of cos x is minus sin x. So by using u into v rule, we have these two terms. And then value at 0 is what? Value f dash 0 is 1, cos 0 is 1. So 1 into 1 is 1, and sin 0 is 0. So we have the 1 plus 1 minus 0, that is 1. Then f triple dash x, again u into v rule here, f double dash x cos x as it is, f dash x cos x derivative is minus sin x. So minus plus and minus become minus, u into v rule. Then I can here u into v rule, but negative sign is that. So f dash x into sin x, negative sign, minus plus, but in bracket. So if you write here plus, then write in bracket. So if after effect of negative sign, we have minus fx sin x derivative is cos x. And then we have this f double dash x cos x. This two terms becomes minus 2 times f dash x sin x minus fx cos x. Okay. So this is the third order derivative, and then its value at 0 is 0, because f double dash 0 is 0, f double dash 0 is f double dash 0, here is f double dash 0, here, right? F double dash 0 is 1, f double dash 0 is 1, cos 0 is 1. So value of f triple dash 0, f double dash x, f double dash x is what? So right here f double dash x as f double dash 0. If we find the value at 0, then f double dash 0 is 1, and cos 0 is 1. So right here value 1, this is 1, this is 0, and this is what? F of 0 is 1. So we have the value of this quantity is 1, value of this quantity is 0, and value of this quantity is 1, and 1 minus 1 becomes 0. So f triple dash 0 is 0. Okay. Then fourth order derivative, again u into v rule here, f triple dash x cos x, and f double dash x derivative of cos x is minus sin x. So minus f double dash x sin x. Again here is u into v rule, 2 f double dash x sin x minus 2 f dash x sin x derivative is cos x, minus again f dash x cos x, and minus fx sin x, cos x derivative of sin x, cos x is minus plus sin x. Okay. Then value at 0. So f triple dash 0 is what? F triple dash 0 is 0. So this quantity is 0. F double dash sin 0 is 0. So this is 0. Then f double dash x is 0, sine 0 is 0, so this quantity is 0, and this is minus 2, f dash 0 is 1, f dash 0, f dash 0 is 1. So we have the value of this quantity as a minus 2, and the value of this quantity is f dash 0 is 1, cos 0 is 1. So this is minus 1 and this is 0. So we have minus 3 as the value at 0. Then by Maclaurin's theorem, right? Maclaurin's theorem that fx is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash 0 plus x raised to 4 by 4 factorial f raised to 4 0 and so on. Fx is equal to, and then fx is e raised to sin x. Right, in the next step here, write fx is equal to, this is the Maclaurin's theorem. So then fx as e raised to sin x is equal to f of 0 is 1, f of 0 is 1 plus f dash 0 is again 1 plus x square by 2 factorial f triple dash f double dash 0 is 1, x cube by 3 factorial f triple dash 0 is 0, so this term becomes 0, x raised to 4 by 4 factorial into minus 3, here minus 3 and so on. So its expansion is that we have 1 plus x square by 2 x, this 4 factorial means 16, 4 into 3 into 2, that is 24, and this 3 by 24 means divided by 8, x raised to 4 by 8 plus so on. So this is the expansion of e raised to sin x. So in order to the expansion of the function about x, we have to use the Maclaurin's theorem. But if I have to expand the function in the ascending power of in the power of the some bracket, then we have to use the Taylor's theorem. The next example is expand cos hyperbolic x and sine hyperbolic x by Maclaurin's series. So we know that cos hyperbolic x or cos x is e raised to x plus e raised to minus x by 2. So this is the value of cos hyperbolic x, cos hyperbolic x. It is not cos hx, it is cos hyperbolic x or cos x. It is e raised to x plus e raised to minus x by 2. It is hyperbolic function. And e raised to x is this expansion of e raised to x is 1 plus x square by 2 factorial x cube by 3 factorial plus x raised to 4 factorial and plus on. And e raised to minus x expansion is just replace x by minus x. So we have here minus x square is plus, so this plus sign remains as it is. Minus x cube is minus x cube, and minus x raised to 4 is plus x raised to 4. So this is the expansion of e raised to minus x. Then cos x is e raised to x plus e raised to minus x by 2. That is 1/2 divided by 2 means into 1/2, and the expansion of e raised to x plus e raised to minus x expansion. And then addition is what? 1 plus 1 is 2. And then x minus x becomes 0. X square by 2 factorial, and this x square by 2 factorial becomes 2 times x square by 2 factorial. A minus x cube by 3 factorial and my plus x cube by 3 factorial becomes 0. And then x raised to 4 by 4 factorial plus x raised to 4 by 4 factorial become 2 times x raised to 4 by 4 factorial. And that take the 2 as common, and then 1/2 and 2 becomes 1. So we have 1 plus x square by 2 factorial, x raised to 4 by 4 factorial plus x raised to 6 by 6 factorial and so on. Similarly, the expansion of sine hyperbolic x. So sine hyperbolic x is what? E raised to x minus e raised to minus x by 2. So this is the definition. And therefore, in the same method, we have 1/2. Sine hyperbolic function is 1/2. Right? E raised to x, right? Just here minus sign and this bracket. And if after effect of negative sign, we have the answer what? All the positive terms become negative and negative terms become positive. And then what we have? That 1 and minus 1 become 0, and x plus x become 2x. Then x square minus by 2 factorial and minus x square by 2 factorial become 0. And x cube by 3 factorial and plus x cube by 3 factorial become 2 times x cube by 3 factorial. In this way, 2x raised to 5 by 5 factorial, 2x raised to 7 by 7 factorial, and that 1/2 and 2 becomes 1, and therefore we have sine hyperbolic x as x plus x cube by 3 factorial plus x raised to 5 by 5 factorial plus x raised to 7 by 7 factorial as the expansion of sine hyperbolic x. So using the Maclaurin's theorem, we have the expansion of these functions. Assume the validity of expansion show that 1 half f of x plus h plus f of x minus h is equal to this value. So by Taylor's theorem, f of x plus h is what? This is the Taylor's theorem, that f of x plus h is what? Fx plus h f dash x plus h square by 2 factorial f double dash x h cube by 3 factorial f triple dash x x raised to 4 by 4 factorial f raised to 4 fx and so on. And what is f of x minus h? Just replace h by minus h. So we have minus sign at this place. Minus h square become plus h square. So this plus as it is. Then minus h cube becomes minus h cube. So this plus become minus. Then minus h raised to 4 becomes plus h raised to 4. So we have plus as it is and so on. So adding these two. So adding these two, f of x plus h and plus f of x minus h is equal to this fx plus fx become 2 times fx. Then this h cube by 2 factorial. This h f dash x and minus h f dash become 0. And this h square by 2 factorial f double dash x and this plus h square by 2 factorial f double dash x becomes 2 times h square by 2 factorial f double dash x. Okay. Then this becomes 0 and this is 2 times h raised to 4 by 4 factorial f raised to 4 fx, this addition. And then take that 2 as common and shift to LHS. Shift that 2 to LHS. That take 2 as common and shift that 2 to LHS. We have 1 half f of x plus h plus f of x minus h is fx plus h square by 2 factorial. Actually here is 2 times h square by 2 factorial. So 2 get common and shifted to LHS. So fx plus h square by 2 factorial f double dash x plus h raised to 4 by 4 factorial f raised to 4 fx and so on. We have this. So expand these functions. So this is the problem for homework. E raised to x cos x. So use the log sec x. So to prove this, use the Maclaurin's theorem. That is, let fx is e raised to x cos x. Here is fx is log sec x. Then use the Maclaurin's theorem. That is, find f0, f double dash 0, f dash 0, f double dash 0, f triple dash 0. First, this is fx. Then find f dash x, f double dash x, f triple dash x. Second order derivative, third order, fourth order, fifth order. And then write the Maclaurin's theorem that fx is equal to f of 0 plus x f dash 0 plus x cube by 3 factorial f triple dash 0 plus x raised to 4 by 4 factorial f raised to 4 0 and so on. And just substitute the values. Fx as e raised to x cos x and the values of all the remaining. Similarly, for this problem, so solve these two problems. E raised to x cos x and log of sec x. Answer are given. So it's the remaining problem we will see in the next lecture.